Thank you so much for having me today. I'm really excited to give this talk. Like I was introduced, my name's Anju. I've been at Bloomberg for 8 years and change now. Um, Before Bloomberg, I was at IBM Research for 5 years in the math department. My background is in numerical linear algebra and optimization. But for almost a decade and a half now, I've been practicing machine learning, natural language processing, information retrieval, and time series analysis. So anyway, let's get started. The first thing is, I don't know the audience that well, so I thought I'd introduce Bloomberg to you. Bloomberg is a fintech company. It's been a successful market leader in this space for almost 40 years now. It was started in 1981. What you're seeing on the screen is what we call our premier product, the Bloomberg Terminal. It's a place where you can get market data, which is, if for stocks, that would be stock prices and other information like that. You could get news, you could get analytics, and you can also trade with other financial professionals. So think of it as like a one-stop shop for all financial information, including the ability to trade. So that's a little bit about Bloomberg. Like I said, it was founded in 1981. We have around 325,000 plus subscribers in 170 countries, and this is for the Bloomberg Terminal. There are also enterprise products on top of this. As a company, we are around 20,000 employees, 6,500 odd engineers. We also have one of the largest journalistic branches in the world, and we have a very strong data team, which is which has like domain experts in pretty much every asset class that we deal with, every data set that we deal with. So people who know fixed income really well, equities really well, derivatives really well, supply chain really well, companies really well, ESG really well, and that adds to the strength of our AI. One thing I'd like to point out is we are big believers in open source. We use open source software for our AI stack. We also contribute back to open source. In addition, my background in research is not unique in my group. It's very common that people come from a similar background. So we are also big believers in giving back to the academia from which we take so much. So publications, fellowships, research grants, all of these are things that we sponsor at Bloomberg. My group itself is around 200 and odd researchers and engineers, and we practice pretty much every discipline in AI. And today I'm going to talk about one of the areas we work in, which is news and research. So without further ado, let me get started with my talk. If you have any questions, please just post it in the chat, and if one of the organizers can read the questions out, because I don't know how to exactly pay attention to the chat room and speak at the same time, I'll be able to take questions even if it's in the middle. Okay, so the topic is search and discovery in news and research. Now, I'm assuming most of you know what news means. Just to give you some color on what research means, research for us are reports that are written by analysts that target a particular financial sector like oil or a particular company and do detailed analysis on the outlook, the health of that company or health of that sector, and it helps you form an opinion about whether you should invest in that particular instrument or not. In addition to this, supplemental material might include earnings transcripts, filings that the company has put forth, and CEO newsletters and other press releases that might come with the company. So that's what we mean by research. And so, like, news and research play a very critical role in both the buy side and sell side investment process. So that's what news and research means. And as you can imagine, the volume of news and research on any given day is immense. So we need to help search and discovery, and that's what this talk is about. So how do we think about search and discovery? We think of it in the following way. The first one is, if you want to enable search and discovery, you really do want to model the useful world, and I'll go into detail about what modeling the useful world means. The second bit is, it's great that you model the useful world. So you know, in finance, that means you know what are the companies in the private sector, in the public sector, you know the supply chain relationships, you know the different securities being offered by those companies and governments. But that's not enough, right? You also have to acquire high quality news and research content. And once you've acquired this content, you need to enrich. And I'll talk a bit more in detail about what enriching this content means. And it's a step towards preparing the data to enable search and discovery. Now, understanding the content, enriching it, understanding the entities that play a role in finance is one part of the equation. Understanding who is searching for information and why they are searching for information at different times of the year, different times of the day is also critical. And this is what I mean by understanding users and context. Users being, you know, somebody who's an equity analyst is looking for very different information than somebody who's a fixed income investor. And somebody who's an equity analyst during different periods. So, you know, an equity analyst who is looking for information on the day of an earnings release of a company is playing a very different role than if they are trying to write a report later in the day or later in the quarter. So once you've done these three things, you've understood the audience, so you know who you are trying to service, like search and discovery, who are you doing that for, and you have good content, and you have modeled the world of financial entities well, then you can enable search and discovery. And like, you know, this is roughly how the talk will be organized. Any questions till now? Okay, cool. So moving on. So what do we mean by modeling the useful world? Um, if you look at financial ecosystem, there are actors, companies, governments, people, supply chain, and any news and research you will encounter are essentially about these actors. So understanding the financial ecosystem through a knowledge graph is very, very critical for us. And that's what we mean by modeling every useful entity and relationships between them. What I've depicted in the graph is essentially like, you know, mock diagram of a company, the stock issued by the company, the bonds issued by the company, the industry that it belongs to. So it might be in consumer discretionaries or in oil, the facilities that it owns or the buildings that it owns, the people who work for the company, which exchanges and which indices it belongs to, and so on. So a concrete example would be like, you know, if I had to model oil, right? So along with the concept oil come oil industries, different types of products like crude, different entities like OPEC that deal with oil, different products that are built out of this. So like asphalt, bunker fuels, feedstocks, and fuel oil. And understanding all of these things helps us enrich content and helps us service our clients. So again, another view towards that, I've shown British Petroleum and its supply chain, and you'll see that, you know, British Petroleum has many peers. These are companies that are similar to British Petroleum. British Petroleum stock is part of many indices. It also is like, you know, you can look at its balance sheet, its board, its executives, analysts who cover British Petroleum, the exchanges where British Petroleum is listed, so you can buy and sell stock. So all of these are modeled in the Bloomberg knowledge graph. And that's the way that we like, you know, that's our grounding for any kind of search and discovery we enable. So now that we've modeled this, so this boils down to a few 100 million entities and billions of edges, billions of like relationships between those entities. Once we've done that, we need to acquire and enrich content. Now here, it's a graph showing the growth of relevant financial information. You can see from 2008 till 2021, where till 2021, when this graph is cut off, you'll see that there's been a phenomenal growth in the amount of information being published on any given day. There are around 200 billion messages that are financially relevant being published any given day. So this highlights the importance of enriching the content in a way that allows us to surface for any given user in any given context the right information. So let's see what that means. So the first thing I'd like to say is, events move markets, and either you're present physically at an event or you have to read about the event or watch some news about the event and whatnot. So in all forms, it's important to understand the role of unstructured data like text and speech and images that moves financial markets. So, according to a study, 80% of all pertinent data for financial decision making is unstructured text. These come in the form of company filings, press releases, news, analyst reports, chats, emails, client feedback, alternative data sources like credit card data or bills of lading information. And where we really use artificial intelligence is to take this data, enrich it with topics and entities and sentiment and importance and salience and relevance, as we'll discover soon. And this helps information discovery and search of information. And particularly in our news department, we process more than 2 million news articles that are financially relevant any given day. We have an index of more than a billion articles that are searchable on at any given time, and we are able to ingest, enrich, and deliver the content both in the search and discovery spaces within half a second, both for monitoring and alerting. So this is a scale of operations at Bloomberg. So what does acquiring and enriching content really mean? So let's think about acquiring content. So obviously news, the traditional news, many of you are familiar with, but increasingly social media plays a role in the financial industry. So here I've shown a tweet by Bill Ackman, who is a financier. Pershing Square Holdings is his company. He acquired a large number of shares in Netflix, and it immediately gets a boost as a result. And you can see it both in the price chart that I've depicted, but also later in a news article that was written about it. And of course, if you're a person who has the time to read every financially relevant tweet and you're following Bill Ackman, you'll be able to just read about it. But more often than not, you have many such financial actors that you need to monitor for many companies. And the right way to deliver this information is if we are able to do entity recognition, link Bill Ackman to the financial professional, understand what are the entities that occur in this tweet. So now Netflix and Bill Ackman, understand salience. I mean, the tweet is pretty salient about Netflix. Understand the sentiment, and by this I mean the financial sentiment. I don't mean whether it's a happy thought, a happy tweet, or a sad tweet. What I mean is, does the tweet contain information relevant to Netflix in a manner that Netflix's stock is bound to increase or decrease? And that's what we mean by positive, negative, or neutral sentiment in the finance space. All of this helps us deliver the right information to our clients. Another example of real-time multimodal data is a earnings call So every company, at least in the Western world, every company holds a quarterly earnings call before giving its earnings statements. Elon Musk was in one such earning call, and based on a comment that he made when an analyst asked a question, you'll see that the stock price decreased rapidly because the question was not completely answered. Again, you'll see the importance of multimodal data. In this case, it's like, speech that gets real-time transcribed, then gets entity linked. Salience is determined as in, like, you do get news stories that tangentially refer to a company. So you want to be very careful about, once you have entity linked, you want to be careful to ensure that the content of the story, especially if it's a long story, can be attributed properly with the right importance to the company. It's not just a matter of linking it. You also need to know whether the story is primarily about that company or about that person or not. Also, topic classification, summarization, all of these are tools which aid search and discovery in finance. So these are not, like, social media and press releases are not the only kind of documents that we do search and discovery over. Earnings filings come in, like, variety of formats like HTML, PDFs, charts, graphs, and we need to be able to understand, and in this slide I've depicted table understanding and chart understanding. We need to be able to understand such multimodal data in order to answer client questions, and do this with very high precision and recall. So all of this put together, what is the base layer of enrichment that you would need for a document? In this case, there is a story about British Petroleum trying to sell a stake in a Russian company after the war started. And you'll see that we use AI to enrich it with topics, with entities, and with salience code. So, like, we have thousands of hand curated topics. We have, like, entities of financially relevant people and companies and corporations. And we've added all of this information along with salience. And that is a base layer of enrichment that you need to enable search and discovery. So now assume that you've modeled the useful world and you have, like, a point in time accurate knowledge graph. I do mention point in time because anytime you get a news story, you can't assume that you're only getting a news story about today. You are sometimes asked to process news and research content that is from maybe 5 years ago. So you'll need to know which entities were active 5 years ago, and certainly, like, linking companies that did not even exist 5 years ago, or uh, companies that have been merged or acquired by other companies. It's not accurate. So we need everything to be point in time accurate. So now that you have the useful world modeled for a lot of content in news, social media, and research, you've ingested it, you have enriched it with topics and entities and salience and sentiment, you have a rich index over which you can do search and discovery. But first, you need to understand the users and the context in which they are searching and trying to discover information. What I mean by that, in this chart, you will see how I perceive the world of finance. So on the very left, you have people who save money, at least I try to. So companies, charities, governments, individuals like you and I. Um, and then there is the financial world, which consists roughly of, like, buy side and sell side. Buy side are people like, wealth managers, sovereign wealth funds, insurance companies, pension funds. Sell side, which is investment banks and other brokers, like, your Goldman Sachs and JP Morgans of the world. And then there is an ecosystem around them of central banks, credit rating agencies like Moody's, governments, because remember, governments also issue bonds and such, companies and, like, even big companies, they have to manage their wealth, they have to manage the perception. So, like, they also are part of the financial ecosystem. Sell side analysts, investment consultants, etc. All of these people have Bloomberg terminal accounts, and you'll have to understand what role they are playing, because different roles have different needs. Like I said, equity analysts, fixed income traders, derivatives traders, sell side people, buy side people, they all have different information needs. And the second thing is, at different times, and I'll have an example up shortly which tells you what different times mean, you also have different information needs. So for example, a financial research analyst whose job is to have a deep understanding of a particular sector or a particular group of companies, when it is earning season, as in when it is close to the time where the companies that that analyst is covering are starting to disclose their quarterly reports, they need to really review the forecast, because a company is going to disclose its reports. You want to know what are the expectations before the disclosure, so you can form an opinion as to whether the expectations were met or they were not met or they were exceeded. You need to update your models in case you are modeling them, and you need to listen to conference calls. But since you can't listen to all conference calls, here you're really counting on the assistance of transcription, alerting, and monitoring. But at the same time, if you're a financial research analyst who's been given a new company to cover, so like somebody comes to you and says, hey, why don't you start forming an opinion on, I don't know, like Tesla, then you need to find and read all the relevant documentation and financial reports of this company for a large enough time in history. You need to assess the future performance, you need to read others' commentary, you need to read others' opinions, and you need to annotate some documents and form an opinion on, like, what do you believe is the future of this company. So same person at different times trying to do different things has different information needs. So now assume you kind of know who your users are and at different times what they're looking for. You already have an index that's enriched, you have modeled the world. The next thing is, just enabling search. And what does enabling search means? In this space, in this slide, I show like a query, right? So somebody types in a natural language query, Delta last year, and you need to understand, what does it actually mean? Is somebody searching for the airlines Delta? Are they searching for the COVID variant Delta? And then retrieve all the relevant documents from different collections. Like I said, there's news, there's social media, there is earnings reports, there's transcripts, there's research reports, and then you have to retrieve the right results once you've understood the query. Another complicating factor is obviously the multilingual nature of information. Here, you'll see that somebody is searching for information in Japanese, and you'll have to be able to parse this, and a it's a multilingual case where the financial language is sufficiently different that Bloomberg has to bake its own translation for this. So what does this mean? What does query understanding mean? On the right, if somebody types in oil last week, the way we parse it is to be able to understand that when somebody says oil, they really mean a topic called oil. And therefore, we should retrieve all documents that have anything pertaining to oil. Last week really means a time horizon between 1 week and today, right? Or if it's a complex logical structure such as German or French parliament elections, you need to understand that German and French here refer to governments, and that parliament elections really applies to both French and German in this case. So again, elections is a topic for us. You'll also need to have the ability to understand open vocabulary. So Pandora Papers, for those of you who don't know, look it up what it was. You'll have to understand that it's a keyword search, Pandora Papers, or was it really about like a company? So you'll really need to understand how to parse the query. In the Bloomberg ecosystem, like I said, there are many players, people who are interested in like bonds, people interested in charting, people interested in macroeconomic factors or equities or holdings or news. or people who are just searching for other people in finance, and understanding natural language queries in each of these domains is a problem, a semantic parsing problem to solve unto itself. And therefore, when you get a generic query, we'll have to invoke several parsers in the backend and rank against all the parsers to understand what's the most relevant parse. And then look at the results that are being returned to really understand what are the results to display. So this is just like a snippet of how relevance ranking is done in the news ecosystem. So if you look at the query here, it says oil. The gray bar is the relevance ranked result. Everything below is time ordered. In news search in particular, time ordered results are quite important. But we really count on the gray bar to provide a snapshot of all the relevant content with respect to the query. So what's our approach? We clearly have to balance the importance, novelty, and recency. We need to look, you can see that it's a diverse set of results that are provided, and we use a combination of state-of-the-art NLP and ranking models. NLP because you have to understand the query, enrich the query. Many times retrieval these days uses NLP heavily, but then you also have to resort to like actual ranking approaches to rank the results. The data that we use is implicit data, as in, what do we think are the right data points, what kinds of results have provided good hits before, explicit annotations from our experts on a variety of queries. But also we count on the Bloomberg knowledge graph to expand topics such as oil to things that are about oil. So, oil is not just one topic, but there's a collection of items that are about oil. So that's about search. That's when you know that, but that's when the client understands what they're looking for, and they just want you to discover that information, that they just want you to find that information. Discovery is the flip side of the argument, where in an ecosystem like Bloomberg, where there are tens of thousands of data points you could be looking at any given time, how do you help the client navigate and find the right information? Not when they know exactly what they're looking for, but when they are in the mood to discover. Just to give you an example, the Bloomberg terminal, you can think of it as a set of web pages. Each web page is called a mnemonic or a function. There are around 10,000 plus functions. One set of functions will tell you everything about fixed income instruments. Another set of functions will tell you everything about news. Another set of functions will help you understand all the research content. So that's what I mean by functions. Then there is unstructured data, right? In this case, you're seeing somebody's trying to understand what does AT&T really look like? Give me some blurb on what kind of a company AT&T is. Chart me the price, the stock price of AT&T. Tell me some important information like the price change in the last day, the 52-week high and low, things like that, which is structured information. Also tell me some estimates about AT&T, tell me some stuff about dividend, which is things that are issued with stocks. And finally, also tell me a bit about the board. So you have a diverse set of information, and trying to discover where you should explore this information is hard. And this is how we help. When you start typing in something into the terminal, so we have a command line, much like you have a search bar on a browser. We start trying to help you with autocomplete. And this allows us to help our clients understand what kind of questions they could be asking. So in the top, you can see Google SHA will autocomplete to shares plotted against Apple shares. It's an interesting thing to check because they are peers in the technology sector. P can, if you just type P, you may get a completion saying positive news about Meta because that's been trending on that day. So this is the kind of discovery that we enable. The challenges obviously are the cold start problem, compositionality. So how do you know Google has to be plotted against Apple? Why not IBM? Why not Intel? Temporal drift, things change over time rapidly in finance. The other thing is when you enable autocomplete driven discovery, you want to be sure that the query can be parsed properly and results can be returned that are meaningful. Um, so like, it's an interesting problem because we do need the autocompletes to actually return meaningful results. Um, you'll see like, there's so much ambiguity. So assets of Lloyd, for example, it could be Lloyd the bank or Lloyds of London or Lloyd Blankfein the person. So you really need to like, discovery can be aided by autocomplete, but you really need to have a grip on what kind of results could be returned and make sure that you don't offer autocompletes that don't have meaningful results returned. Um, on the terminal browser, just like in the query parsing case, I told you that there are people interested in equities, in bonds, and different asset classes in news and in research. There's also like when you're trying to do autocomplete, there is a different autocomplete model for each of these. Just like there's a different query parsing model, there's a different autocomplete model for each of these domains. And so when people start typing something in, what they see are the results of a federated ranking system on top of these autocompletes. And we really need this to be fast as well. So like, we are equal parts engineers and researchers because the speed of completion actually matters. And it's actually like a fascinating problem to solve. So you'll see like, you'll see like a snippet of, I hope everyone's able to actually see the short clip, and you can see that somebody's searching for trends on the Delta variant, news trends on the Delta variant, and you can see how in 2021, after May, when the search was executed in July, you'll see that there's a huge growth in stories published about the Delta variant. You'll be able to see key news themes, which is a abstractive summarization on top of clustering that we do for this, and we do all of this in real time. Again, we have like papers about this. If you can search for papers on tech@bloomberg.com/AI, you'll find all the papers that we published on this topic. So again, like, analytics aid discovery, right? And what I mean by that is it's well and good to return individual stories, individual research articles, but sometimes what you really want is a 3-month, 6-month, 1-year picture about a topic or a company. And that's what we mean by analytics. And again, like, analytics help, but so do summaries. So here what you see is a function we've built which allows you to pose a query. In this case, the query is Tesla, and also specify a time range. In this case, that is 3 months. And we are able to retrieve stories where the entity Tesla was a primary actor, cluster them on the fly, and for every cluster, understand what's the key theme in that cluster, what are some exemplar stories in that cluster, and present this in real time to users. On the right, I've put in all the different natural language processing and machine learning tasks that are executed in order for this function to be, in order for this application to have been built. And it's also a paper at ACL, so I'd welcome all of you to check it out. So I want to leave enough time for questions, so that's nearing the end of my talk. But before that, what I really want to say is, in order for you to build any kind of search and discovery, the first thing is, and this is not so much about search and discovery as it is about like AI that we've found through, continuous maintenance is very, very critical in any domain where information changes really fast and data distributions change really fast. And the way to build search and discovery is, like I said, you need to do enrichment of all the articles that are coming through. What is the document about? What are the companies, people, topics present in this document? What are documents that are similar to one another? All of these you need to pre-process and store. You need to be able to understand the users and context, and then be able to like rank and understand the queries with respect to the documents that you're retrieving. And sometimes analytics also help, as in instead of just retrieving a set of documents, you may want to dig deeper into the trends that you're seeing across the set of results that you've retrieved. And on top of this, you can search, you can monitor, and you can discover. And again, like, this is just like to reiterate that whenever we build models, it's never that the first model is the best model you build. So what we make sure we have is a continuous integration and continuous deployment process, which allows us to iterate really quickly on the quality of all the models that we use for search and discovery. This is a set of publications which is already out of date because we've had a few more papers since then. And a lot of these publications drive innovation that we put into our products. So again, thank you for inviting me. My name is Anju. You can reach me at pkambadur@bloomberg.net. Check out bloomberg.com/careers. We are hiring, we are growing tremendously in 2023. So like, if you're interested in natural language processing, in information retrieval, in time series analysis, or anything in that range, in general in AI at large, please get in touch. So that's the end of my talk. Thank you.
Question from Melissa Han. Do you find that Twitter often messes up you with your search results?
No, not really, because roughly speaking, I believe there are around 500 million tweets or thereabouts that we look at, and we only find a % of it to be financially relevant, or maybe like it's 3 or 4%. And the way we do that is not just using machine learning and AI, where we identify, like, let's say we have annotations of tweets that are financially relevant, and then we can look for tweets that are similar to those tweets, but then you create a recommendation bubble. So the way we avoid bringing in tweets that add noise is by augmenting our artificial intelligence with our excellent data, product, and editorial division. So like I said, if you combine all this, we have around 6,000 people who are either journalists or data analysts, and they tell us who are the verified handles we should be following, what are the topics that we should be ingesting within Bloomberg. And in addition to AI, knowing whom to follow, which tweets to bring in, already adds a very strong signal to, like, so it reduces the noise for us in some sense. So the tweets we bring in are actually quite valuable. I can't understate the importance of having understate the importance of having a strong grasp of the domain that you are searching and discovering over. And in our case, that is expressed through our data organization, our product organization, and our journalists. So like they help us out tremendously.
We have a question from Vivek Pandian. How do you calculate sentiment of tweets and articles?
So it's a model. So I suspect I can answer your question in two ways. The first one is there's no shortcut, which is you need to have excellent annotations. Sentiment for us is a pipeline. It's not just like, one model. Like I said, you have to first eliminate noise. And of those articles where the noise has been eliminated, you have to do entity recognition. You have to do entity linking on top of that. Once you've linked the entities, that's not enough. You need to still have a salience model that determines if the article is indeed about the entity. If it's a long article, then you'll have to extract out content which is specific to that entity, let's say like an equity or a commodity. And then on top of that, you need annotations from domain experts who tell you, is the content something that is net positive for the entity or not, right? To give you an example, if there is a company which announces austerity measures, like, they're going to not hire, maybe they're even going to have layoffs, most of us would read it and assume that it's a negative sentiment. But depending on the context, it might actually be net positive for the stock price of that company. And that's what I mean by, like, the last step is actually domain experts annotate the data. And that's how, and then on top of this, we have calibration procedures that enable this to be used as a signal in downstream models. Maybe there's, like, portfolio investment models that run. So when we change our models, the calibration of probabilities of positive, negative, neutral, it has to be done very carefully. So we can't just keep, like, changing the distribution of probabilities that we give out to our clients. I hope that answers the question.
The last question is from Alex Smith. Is fake research a problem to manipulate a market, for example? How do you solve it?
Yeah, so I think in research, there is less of a problem. Research is, people in finance don't just buy research from anybody. Just like the same comment I made about Twitter, where you kind of have to know your sources. Even in research, you have to know which analysts are good at covering which company, and you don't usually read just one research report. You actually read several opposing or contradicting opinions, and then you form your own opinion about like whether the company or the sector is a good investment vehicle for you or not. So absolutely, again, like, I'm sure there's tons of sketchy research out there, but at Bloomberg, because we know our sources, we, like, we're able to offer high fidelity information. There's no shortcuts to knowing who's producing the research and, like, how credible they are and whether it's a good source of information or it's not a good source of information. And for some of these veracity projects, we do use AI, but I also want to say that, being a company that's existed for 40 years, we have a very deep network of experts who know where to look for information, and we use AI to augment processing of that information.